So now let's create structure in Vista, and the procedure is I have already shared by PPT, but because everybody, like, it is very important that we should know what are the steps in Vista also. So just drag your file here and it will open the file. Now you will see this is your system, and as I already told in PPT that you have to edit bonds. In bonds it is not going to delete the bonds, it will just uh, delete the bond between molybdenum and sulfur. So apply. Now you have your structure, and that's it. You have to just first you have to just save this file as an postcard. Now because I have already shared it as an postcard, but let me just share it. Okay, so it is not showing, so we have to just export it. So we have to export it, not just save this. Export, we can export. So I will just use this as a bulk, and because I have already created so many bulks, so I have to just see which number I can take. So bulk 2 okay, so mo s2 bulk, and I will just use second option 2 2 subscript, so that okay. Now we have this file in, we have to save it in a Cartesian coordinate because we don't want our coordinates to be normalized with respect to box. So let's see what kind of file it is. Okay, so it is just molybdenum 2, because so it is, you see, it is not it has show it is saving 2 molybdenum and 4 sulfur, but we don't want that because we just wanted to create a monolayer. delete delete this atom. Now we have to save, we have to export it as an xyz coordinates. What I feel I have already saved, and we have xyz coordinates, so we can just use them. um, Still, if you want, I can just, for like, just to make it very clear that I am doing it during the video. So we don't want to save any hidden atom, so just no. And let's see which file we have. Yes, this one is our file. So we have to just copy this. uh, we have to copy this, control C. We can just go to our bulk 2 and we can just paste. Now we have to delete this molybdenum because VAS file doesn't work in that way. It doesn't require the atom information, it requires just the coordinates. So it is just 1 and I think 2 and 2 and 1. No, we don't have to. So it's a monolayer. Monolayer. Okay, just save. Okay, so now I will just change this bulk name as a monolayer, or I will just copy this file to show it is a monolayer. But however, we can just drag this file also, but I am just for clarification monolayer. Okay, mono I can just type. So now just drag this file. Your monolayer is ready, and people will say, okay, this is not a monolayer, this is just a simple thing. Okay, but let me just show you. You can go to boundary and you can just extend it. So it is just a visualization. You can always create your file. Apply. So it's a monolayer, you can see. You can also extend it into the y direction. 1 and I think 4 I can take. You can take any number. It is not means necessary that the numbers I am choosing. So it's a monolayer, or it is not necessary that you have to just follow my things. You can edit. You go to unit cell. If you want that exact monolayer, you want the number of atoms to be reflected in your postcard file. So go to 2, just make it 2, and again you have to OK. Yes. Search atom in a new unit cell. OK. Apply. Okay, let's save it. So you can just export data, and this will be your mono 2 is to 2 is to 1. So I am not extending it in a z direction, and because it's a mono layer. So save in terms of Cartesian coordinate. Let's see. So it should be multiplied with the factor 4. So tada. So we have the file for mono layer. Okay, I will just drag it again so that everybody will be clear. Okay, so I think your mono layer is there. You can see it's all up to you how many like atoms you want to take, and what is your supercell for mono layer, or whatever the number of atoms you want to, what it depends on your computation power. Okay, so if I just use this procedure for these two, this will work because those two files are exactly similar. It is just matter of a lattice parameters. All the like structure wise they are equivalent. So for molybdenum disulfide, molybdenum sulfide and tungsten sulfide, this procedure you can use. Let me just close it. Now suppose we have to just create for vanadium disulfide. Okay, let's see. So it is depends on the structure which we are using. So let me just make it. Okay. Okay, so this is our vanadium sulfide structure. Just again you have to delete the bonds, go to bonds, delete them, simple, apply. Now just to create mono layer you have to just delete these two lines as they are replicas. Replica means if you just save this as an xyz formats it will just auto populate it. Okay, but we don't want that. So again you have to delete, you have to delete and you have to save it as an xyz. So first you have to save postcard as an xyz, and then you have to just let me just export data as an xyz. So it's in postcard I have already, so I will just share it as a bulk. I will just saving it as a bulk 1. Okay, so it's in Cartesian coordinate, so it will save the actual number of atoms. Now I will just wanted to save an xyz coordinates of these files. So now we have to change it into the xyz. It's a mono layer. We have already have xyz coordinates, but I'm just saving it for sake of showing to everyone. Mono layer, we don't want to save hidden atom. Now we have mono layer, we have bulk. So let's copy these atoms. So I am just copying it from notepad. So please, if you have PyCharm kind of thing, you can always use. Okay. Okay. You can edit the title because I am little bit lazy. So just let's save. Okay, now bulk I can just use in mono layer 2. I am just changing the file name. I am not changing the edit, means I am just changing the file name mono 2, and you can extend it as in the previous procedure I have just shown. Okay, just let me. So now this is your monolayer. Oh my god, why you are not? This is your monolayer, and you can always extend. You can just use boundary. I will just use -2 to +2 just for showing it. Or you can use any number, not in z direction, but you can in xy direction you can use any number. So see, this will be your monolayer, and you can definitely use it. Now I think this procedure will work for these two kind of system also. No, this for this kind of system it for platinum. Okay, so this is actually a different folder. This for this it will not work. So I think this for vanadium sulfide it will work. So I will just copy this file to the, I think, vanadium sulfide. Okay, so now we will move to our next system. Each and every time I could have prepared 4 videos, but because I don't want to um, I don't want to waste my time for making more videos, so that will I am just showing it in a one video. So first I have shown the PPT so that everybody understood, and then I am just showing the how to do it in VESTA. So first you have to again open VESTA. Let me just drag this file. You can always download these files from materials project or crystallographic open database. So now we have to just one thing we have to do. Here it is not showing bonds, but suppose if I have chosen these two system, it will show bonds. So definitely in that case we have to delete bonds. So okay, again it is not showing. In I think is this case it is showing. So we have to, for this case we have to actually delete the bonds. Delete the bonds means in visualization we are deleting the bond. Actually we are not deleting the bonds. Okay, so delete. So now if you'll see, this will be, now these three systems are almost same. So the first step I will just show. So you have to go to unit cell and you have to transform and just extend it into a z direction. Okay, so yes, search atom. Okay, apply. Now the thing is, this is exactly similar to the the structure I have discussed for vanadium sulfide. If you remember, the vanadium sulfide system is like the same. If you just compare now, this is exactly the same. Now just you can, okay, so I have to just delete bonds again. Okay, bonds I have to delete. Now just see, these two structures are similar, they are not different. We just by extending it in a z direction they become similar. So procedure will be the same. You have to whatever you have to first save this file as an postcard, delete those two lines, delete 3 atoms, delete these 4 atoms, and just save xyz, then postcard, then copy it. Okay, however what I feel is, what I means, I don't know whether I am doing it correctly or I am doing it, there must be some mistake, but still the procedure I will try to show, and those who know the exact procedure and those who can just comment that whether it's a right or wrong, because it is not that we always do everything is right, but because I know the steps, if somebody will correct, or it is actually correct, but I just want an clarification, so please comment if anybody know how to do it. Okay, so again we have to go to bonds. Oh sorry, we have to edit bonds. Delete. It will create, actually these bonds create confusion in my mind, so I just try to remove those. So now we just wanted to see the monolayer. Monolayer, it is kind of not able to MC, so I will just extend it. I do it to extend. Sometimes I do it for just to see the clear picture where are the monolayers. Okay, so just okay. Okay. Yes. Yes. Okay. Apply. So if I correctly see, this is my monolayer. So okay, now let's just delete those two atoms. Okay, first I will just save it as bulk. Export data, just type in bulk. Oh, don't want to save. Okay, just file export data, because we have to just choose option bulk, and we have to just change it as a postcard. Now postcard save. Okay, so Cartesian coordinate we have to use. I am again pointing it out. Again, now we have to like delete the replicas. Okay, so this we have to delete, and this we have to delete. Good. Just delete it little bit. Now we have to just delete these, because this is replica. This is also a replica. And delete. File XYZ, export data as an XYZ. Now we have to change it to the XYZ. I already have XYZ file, but I will just make it XYZ2 just to show you. No, we don't want to save any hidden atom. That's why we have deleted them, because we don't want it to save. Now this will be our monolayer. Control C or copy this, and then just paste it into the postcard of bulk. Okay, so I usually what I first do is I just change this number, because if then you can forget what are the numbers. However, you can always check. So let cadmium, tellurium. Wow. So I think this is a very famous material, cadmium telluride. It is, I think it is used in solar cell, maybe solar cell, if I correctly remember. I will just change it as a monolayer. Okay, I think this will work. Wow, it has created the monolayer. Okay, yeah, it's created the monolayer. So now just extend in XYZ direction. However, what I was wondering that they, like, in place of tellurium, it could be means they can interchange their position. So I don't know what are the phases. It could be possible there will be some other phases, but standard procedure is like that. I will just apply. Wow. So I think this is the monolayer. You can also extend it in Y direction. So I hope I have covered 4 different type of system, and please try to see the procedure very carefully, and if you have any comments or queries or any doubts, you can always ask. And please like, subscribe and share my YouTube channel, because it's an very like it's my hard work, and I really wanted to grow my channel. However, before just closing it, I wanted to show this is a very complicated system, lithium manganese oxide. It's a spinel, and creating a monolayer from this system will be a very difficult task. However, those who are interested in like see how to create a monolayer for lithium manganese Mn2O4, please comment. And those who want a monolayer for this kind of system, and those who wanted to just learn, because it's a skill. If you learn it, then you can use it. So those who want to learn how I have created the monolayer for the structure, please comment. Otherwise, because I don't think so, the spinal the monolayer for spinals will be used in anywhere if I just check the literature. However, for practice you can always use this material. So I hope I have covered all the topic. So thank you very much.